This is modern physics. Build up your understanding. Question 4. It is a very good question of photoelectric effect, and you have to use the current electricity concepts also. So let us see what is the question. Question is, there's a plate of area S. This is the plate below one. It is connected to a battery of EMF E. This is the battery, and there are two resistances A and B. Both resistances are R, and now there is a uniform. Light of the plate is illuminated by a monochromatic light of wavelength lambda. So this is the light. The photoelectrons emitted from the plates are collected by the wire grid. So this is the wire grid. Whatever electrons are emitted, those electrons are collected by this. Intensity of the light is I naught. Resistance of the plate is R naught. So plate also has certain resistance, that is R naught. Quantum efficiency of the photoelectron emission is eta. We have to find the strength of current from A and B. So we have to find out the current which will flow from the resistances A and B. So we are going to solve this question from the principle of superposition. So first, suppose there is no photoelectric effect. If suppose there is no photoelectric effect, then what will be the current from these two resistors? It's very simple. We can draw the circuit equivalent of this. This plate has resistance R naught, and these are two resistances which are both are R. So the current in both the resistors will be equal. That will be equal to E naught E divided by R naught plus 2R. So that will be the current if there is no photoelectric effect. So now we are going to calculate the current due to photoelectric effect. Now we are forgetting the EMF completely. Then after that, we will superimpose both the currents. Now to calculate this current, we have to first find out number of photons incident on this plate per unit time. So number of photons, what is the intensity? Intensity is I naught. Intensity is energy per unit time per unit area. So if I multiply by area of the plate is given as S, then I get I naught into S, I get as energy incident per unit time. Now, if I divide this thing by Hc by lambda, what is Hc by lambda? Hc by lambda is the energy of one photon. So this is the total energy incident in unit time, and this is the energy of one photon. So if I divide by this, then you get number of photons per unit time. So these are the number of photons which are incident on the plate in 1 second. Now we have to find out number of electrons ejected per second. So quantum efficiency is given eta. So eta times of this number of electrons will be ejected in unit time, right? So in 1 second, these many electrons are ejected. How to find current? Number of electrons into the charge of one electron. So this is the current which is flowing like this, right? Electrons are going this way, so current will be opposite to that. So let us draw the diagram for this also. This is the total current. Now this current is electrons are going this way, right? See in this diagram which I have drawn. So current is opposite. Now since current is opposite, here comes the most important point of this question. Now as far as photoelectric effect is considered, then these two directions are equally preferred, right? So there is no bias in any of the directions. So there is no reason for the current to be, for a different current to be flowing in these two wires, right? So if there is no bias, then I current, if I current is flowing, then I by 2 current should flow like this, and I by 2 current should flow like that. Now we are going to find out the total current and resistance A. So let us see where was the resistance A. This is the resistance A. Now see these two diagrams simultaneously. Here resistance A. Now due to this EMF source, when we forgot about photoelectric effect, that time the current was in that direction towards right. Right now also it is in this direction. Fine. So what will be the total current in A? I equal to I1 plus I2. This is due to EMF and this is due to photoelectric effect, right? Divided by 2. Now if you see B, in B, due to EMF current was towards right in plus X direction, but due to photoelectric effect it is in opposite direction. So I need to subtract both. So here in B, this is the current due to EMF source, and that is the current due to photoelectric effect, right? So it is a simple question, but again, I think it is very, very important for JEE Advanced, this concept, symmetry concept basically, right? Common sense concept. So it's a very, very important for JEE Advanced. If you have liked this video, please hit a like button to this, and please subscribe to my channel also. Thank you very much. Thanks a lot for all your exams.